Hi friends, in this session we will discuss about refraction of light, refraction of light through a rectangular glass slab and refractive index. Now let us start with refraction of light. Say I will give you some situations that will be familiar to you. If you take a pencil and if you immerse a part of this pencil in water in a tumbler or in a beaker, you can see that the pencil gets displaced at the interface of air and water. Now, if you place a rectangular glass slab on some printed materials or printed letters, you can see that the letters get raised. You might have all noticed one more thing. If you place, if you keep a lemon in a glass containing water, you can see that the size of the lemon gets enlarged. The reason is same for all these cases. It is why? Because when light travels from one transparent medium to the other, the direction of light changes. Now you see the first case. The light from the part of pencil that is immersed in water, first it travels through water, then it enters into air. So two mediums are there. The first one is water, the second one is air. So what happens to the light ray? The light ray changes the direction of its propagation. Why? Because the first medium was water and the second medium was air. Now the second case, the letters seems to be raised when you place a rectangular slab over some printed matter. Why this happens? Here the light from the letters passes through the glass slab first, then it enters to air. So there is also two transparent medium. First it travels through the glass, then it enters into air. The case is same in the third case. It is similar, in the case of lemon. Now this phenomenon is known as refraction of light. That is, the direction of the light when it travels from one transparent medium to the other. This is called refraction. Now, why the direction of light changes when it travels from one medium to other? It's why? Because light has different speeds at different medium. The speed of light in air, that will be different from that of glass, that will be different from that of water. You see, through different materials, light travels with different speed. That is the reason for refraction of light. Now let us consider refraction through a rectangular glass slab. Here we have taken a rectangular glass slab ABCD. Now a light ray is incident on one edge AB of the rectangular glass slab. You see, the incident ray falls obliquely. Now let us draw a normal at the point Q. Now what happens to that incident ray? You can see that the light ray is traveling from air to glass. So there is two transparent media. The first one is air, the second one is glass. So what will happen? The direction of light will change. You see, the direction of light will change. Now what happens to the speed of light? The speed of light gets decreased. Why? Because air is a rarer medium and glass is a denser medium. What do you mean by rarer and denser? It is simple. Rarer means the medium through which light can travel very easily. What is denser? It is the medium through which speed of light get decreased. So here when light travels from air to glass, what happens to the speed of light? Speed of light decreases. So what happens? The refracted ray comes close to the normal. You see, here the refracted ray is QR. The direction of the incident ray changes at the interface of air and glass, and it gets refracted, or the direction changes and the light ray moves in the direction QR. Now can you mark angle of incidence and angle of refraction here? What is angle of incidence? The angle between the normal and the incident ray. That is represented by I1. What is angle of refraction? The angle between the refracted ray and the normal. That is R1. So what happens here? Here when the light travels from air to glass, speed of light decreases and the refracted ray comes close to the normal. Now let us look at what happens at the other edge of this rectangular glass slab. What is the other edge? That is DC. You see, the light ray travels through the glass slab, that is QR, that reaches at the interface of air and glass, that is at R. Then what happens? The ray gets emerged or the ray gets refracted. Now can you tell me in which direction the light ray will move? Here the light is traveling from denser medium to rarer medium. Why? Because from glass it travels to air. So glass is a denser medium and air is a rarer medium. So what will happen? So here the speed of light ray increases. The speed of light increases. So what happens? The light ray will move away from the normal. So at the first case, at the first refraction takes place, the light ray was traveling from rarer to denser. So speed decreases, the ray comes close to the normal. But here light ray travels from denser medium to rarer medium. So its speed increases and the light ray moves away from the normal. Now can you mark the angle of incidence and refraction here? Here the angle of incidence, that is the angle between the incident ray, that is inside the glass, incident ray and the normal. It is marked as I2 and the refracted ray, that is marked as R2 here. Now if you just extend the incident ray, that is PQ, if you extend that, the direction of incident ray and the emergent ray, what is the emergent ray here? That is RS, that will be parallel. Why these two rays are parallel? These rays are parallel. Why? Because the refraction here takes place at two surfaces. At first at AB, then at DC. At these two sides, when the refraction takes place, the bending of light takes place. This bending of light is equal and opposite. That's why the emergent ray is parallel to the incident ray. And you know the emergent ray is shifted or displaced from the direction of incident ray. It is parallel. So this shift or this displacement is known as lateral displacement, or we call it lateral shift. Why? Because the emergent ray will be parallel to the direction of incident ray. I think it is clear why it is the lateral displacement or lateral shift takes place here. Why? Because at two interfaces bending of light takes place, or you can say the refraction takes place. That is on the edge AB and DC of rectangular slab. So the bending of light at two edges, they are equal and opposite. That's why the emergent ray is parallel to the direction of incident ray. All this refraction follows some rules. So those rules are known as laws of refraction. Let us see what are laws of refraction. The first rule states that, the law states that the incident ray, the refracted ray, the normal to the interface of two media at the point of incidence, those three rays, those three are lying in the same plane. Incident ray, refracted ray and the normal. They all lie in the same plane. That is the first law. The second law is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given color of light and for a given pair of media. You see, refraction always takes place in pair. Here you can see what was the first pair in this experiment. In this experiment, first pair was air and glass. In the second case, refraction takes place. What was the pair of media? It was glass and air. This is also known as Snell's law. So what is Snell's law states? It states that ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given color of light and for a given pair of media. Mathematically, it can be expressed as sin I by sin r equals a constant. This constant is known as refractive index. Now, here when the light travels from air to glass, we say that the refractive index of glass with respect to air is what? Sin I by sin r. Now, let us take some other figure and let us understand the refractive index more detail. You see, here you can see two mediums are given, air and glass. Let us call air as first medium and glass as second medium. Or glass or water you can take. We have taken glass in the first case, so you can take water. Now, light travels from air to glass or water. So, what happens at the interface? Refraction takes place. Let us draw the normal. You can mark angle of incidence and angle of refraction. What is angle of incidence? The angle between normal and the incident ray. What is angle of refraction? The angle between the normal and the refracted ray. So, we have marked angle of incidence and angle of refraction. So, the first ray, that is the incident ray, the second ray, that is called the refracted ray. Okay. Now, according to Snell's law, what is sin I by sin r? Sin I by sin r equals a constant, and that constant is known as refractive index. Now, if you consider another angle I1, for example, let us keep the angle 40 degree, angle of incidence. Then corresponding to that 40 degree, you will be getting angle of refraction here. Let us call that angle of refraction as R1 and the angle of incidence is I1. So, you get R1 corresponding to I1. Now, you find the ratio sin I1 by sin R1. You will be getting a value. Now, what you have to do? You just change the angle of incidence. Let it be I2. Then you will be getting another angle of refraction R2. You find the ratio sin I2 by sin R2. That will give you also a number that will be similar to sin I1 by sin R1. That means sin I1 by sin R1 will be equal to sin I2 by sin R2. That will be equal to sin I3 by sin R3. So, for this given pair of media, that ratio will be always constant. That is known as refractive index. Usually, it is represented by the letter N. Now, here the light is traveling from medium 1 to medium 2. I told you what is medium 1. Medium 1 is air and medium 2 is glass. Here actually we are finding the light is traveling from 1 to 2, medium 1 to medium 2. So, here we are finding the refractive index of medium 2 with respect to medium 1. So, this can be represented as N21. What is that 2 stands? 21 stands? N21 stands for refractive index of medium 2 with respect to medium 1. Then what will be N12? N12 will be the refractive index of medium 1 with respect to medium 2. Here the light is traveling from 1 to 2. So, refractive index will be N21 because we are finding the refractive index of medium 2 with respect to medium 1. So, N21 will be equals sin I by sin R, that is refractive index of medium 2 with respect to medium 1 will be equal to sin I by sin R. This refractive index of second medium 2 can be also found out if you know the speed of light in two medium. Let the speed of light in air be C1 and the speed of light in water or medium 2, let it be C2. Then refractive index N21 also can be found out using the relation C1 by C2. So, refractive index of a medium N21, that is medium 2 with respect to medium 1 equals sin I by sin R, that is also equal to C1 by C2. This will be helpful for you for your examination, for solve some problems. Okay. Now, let us consider some values of refractive indices of some materials. Here we have taken the refractive index of water with respect to air as 1.33, refractive index of glass with respect to air as 1.52, and refractive index of diamond with respect to air is 2.42. You see, the refractive index of water is less than that of glass, refractive index of glass is less than that of diamond. What do you conclude from this? We say that as the refractive index of a material or a medium is less, we say that light can travel with more speed. So there is a relationship between speed of light through a medium and the refractive index. So if refractive index is less, the speed of light will be more. So can you tell me, among these three media, through which medium the light can travel with high speed? Through water, glass or diamond? The light can travel at maximum speed through water among these three cases. Why? Because refractive index is less for water. Now there is one more term you have to understand, that is optical density. As refractive index increases, optical density increases. It is because of this increase in optical density that material doesn't allow the light to pass through that substance very easily. So among these three substances, which material will have more or the maximum optical density? Optical density will be maximum for diamond. Here because refractive index is maximum for diamond. So if refractive index is less, optical density will be less, but the speed of light will be more. If refractive index is more, the speed of light will be less and the optical density will be more. So there is a relation between speed of light and refractive index and optical density. That is, the speed of light is inversely proportional to refractive index or optical density. That is, C is inversely proportional to refractive index or optical density. If refractive index increases, what will happen to speed of light? Decreases. If refractive index decreases, what happens to the speed of light? Speed of light increases. So they are inversely proportional. Now one more point that you have to understand, what is mean by absolute refractive index. Let us consider the first example here. Here in the first example, the light is traveling from air to glass, that is from medium 1 to medium 2. If the first medium is air or vacuum, we find or we compare the refractive index of the second medium with respect to that of vacuum. Is it clear? If the first medium is vacuum or air, we will calculate or we will find the refractive index of second medium with respect to vacuum. This is known as absolute refractive index. Absolute refractive index is nothing but refractive index. So here we have see the what is the refractive index of water? Refractive index of water with respect to air is 1.33. That means here we compare the refractive index of water with respect to air. That means that is its refractive index of water. Now the second case, what is the refractive index of glass with respect to air? That is 1.52. What do you conclude from here? The refractive index of glass is 1.52. What is the refractive index of diamond with respect to air? That is 2.42. That means that is the refractive index of diamond. So in this session we discussed what is refraction. What is refraction? Refraction is the bending of light when it travels from one medium to other. Why the bending takes place? Because light has different speeds at different medium. Next we have seen the refraction through a rectangular glass slab. Here refraction takes place at two surfaces or at the interface of air to glass, then glass to air. So at these two edges of this rectangular glass slab, bending of light takes place, or we say refraction takes place. This bending is equal and opposite. It's because of this reason the emergent ray was parallel to the direction of incident ray. Here at the first interface, light bends towards a normal. Why? Because light was traveling from air to glass, that is rarer to denser. So when light travels from rarer to denser, light will come close to the normal. But at the second interface, that is the interface of glass and air, the light travels from denser medium to rarer medium. So what happens to light ray? Light ray moves away from the normal. Now the parallel distance, the distance between the emergent ray and the incident ray, that is known as lateral shift or lateral displacement. Then we have seen what is laws of refraction. The second law is very important. Sin I by sin R is a constant. That constant is known as refractive index, and this law is known as Snell's law. Sin I by sin R is a constant, that is Snell's law. Here we understood the relation between speed of light and refractive index, or speed of light and optical density. Then we understood about what is absolute refractive index. If one medium is air or vacuum, the refractive index of second medium is termed with respect to that of vacuum. This is called absolute refractive index. Now there will be some numericals from this topic, for your board examination, and you have to remember some formulas, shortcuts to solve those problems, and that will be discussed when we solve the problems from previous year's question papers.